Welcome to Chapter 13.5, The Scientific Revolution. In the mid-1500s, a big shift in scientific thinking caused the scientific revolution. At the heart of this movement was the idea that mathematical laws govern nature and the universe. Before the Renaissance, Europeans thought that the Earth was the center of everything in the heavens. In 1543, however, Polish scholar Nicolaus Copernicus proposed a heliocentric or sun-centered model of the solar system. In the late 1500s, the Danish astronomer Tycho Brahe provided evidence that supported Copernicus's theory, and the German astronomer and mathematician Johannes Kepler used Brahe's data to calculate the orbit of the planets revolving around the sun. His calculations also supported Copernicus's heliocentric view. Scientists from different lands built on the foundations laid by Copernicus and Kepler. In Italy, for example, Galileo assembled a telescope and observed that the 4 moons of Jupiter moved slowly around the planet. He realized that these moons moved the same way that Copernicus had said that the Earth moved around the sun. Galileo's findings caused an uproar. Other scholars attacked him because his observations contradicted ancient views about the world. The Church condemned him because his ideas challenged the Catholic Church's interpretation of the Bible, which said that the heavenly bodies were fixed in relation to the earth, and therefore were perfect. Despite the opposition of the Church, a new approach to science had emerged, based upon observation and experimentation. To explain their data, scientists used reasoning to propose a logical hypothesis, or a possible explanation. This process became known as the scientific method. The new scientific method was a revolution in thought. 2 giants of this revolution were the Englishman Francis Bacon and the Frenchman René Descartes. Both were devoted to the understanding of how truth is determined, but they differed in their approaches. Bacon stressed the experimentation and observation, and Descartes focused on reasoning. The 1500s and 1600s saw dramatic changes in many branches of science. English chemist Robert Boyle explained that matter is composed of particles and behave in knowledgeable ways. Isaac Newton used mathematics to show that a single force keeps the planets in their orbits around the sun. He called this force gravity. To help explain his laws, Newton developed a branch of mathematics called calculus. In the mid-1500s, there was a profound shift in the scientific thinking of the world, and it brought about a final break with Europe's medieval past. At the heart of this scientific revolution was the assumption that mathematical laws govern nature and the universe, and so therefore people could manage and shape the physical world. Until the 1500s, Europeans had accepted the idea that the Earth was the center of the universe. This geocentric view was developed in ancient times by Aristotle and Ptolemy, but by the Renaissance it had become the official church doctrine. But there was a Polish astronomer named Nicolaus Copernicus who challenged this view. In 1543, he proposed a heliocentric or sun-centered model of the solar system, and the Earth and all the other planets revolved around the sun. Copernicus's revolutionary theory was rejected. If the classical scholars were questioned, then all knowledge might be called into question. But careful observation by Tycho Brahe supported Copernicus's idea. Also, Johannes Kepler used Brahe's data to calculate the orbits of the planets. Kepler found that the planets didn't move in perfect circles, however, but they were more elliptical in their revolutions around other bodies. In Italy, Galileo Galilei built a telescope and observed several moons in orbit around Jupiter. He said that these movements were the same as those of the planets around the sun. Well, this contradicted the church doctrine that the Earth was the center of the universe, and Galileo was arrested and tried for heresy. He was forced to recant his theories before the Inquisition. Despite opposition from the Church, however, there was a new approach to science emerging during the 1600s. Scientists rediscovered the Greek philosopher Plato, who saw mathematics as the key to learning about the universe. Francis Bacon and René Descartes challenged the medieval scholarship that sought only to make the world fit into the teachings of the Church. Bacon and Descartes argued that truth is not known at the beginning of the inquiry, but rather at the end. Bacon stressed observation and experimentation. He wanted science to improve people's lives by developing practical technologies. Descartes emphasized human reason as the best road to understanding. In his Discourse on Method in 1637, he discharged all traditional authorities to search for knowledge that was provable. He is famous for his saying, "I think, therefore I am." The only thing that he could not question was doubt. Since he could doubt, he had to exist as a rational being. Over time, scientists developed a step-by-step scientific method. It required the collection of accurate data and the proposal of logical hypotheses to be tested. There were dramatic advances in medical knowledge in the 1500s and 1600s. In 1543, Andreas Vesalius published On the Structure of the Human Body, which was the first accurate, detailed study of human anatomy. And in the early 1540s, Ambroise Paré developed a new surgical technique and tools, including artificial limbs and ointments to prevent infection. William Harvey described the circulation of blood, showing that the heart was a pump, and Anton van Leeuwenhoek perfected the microscope and became the first person to see cells and microorganisms. Medieval chemists called alchemists had believed that any substance could be turned into another substance, and so they tried to transform ordinary metals into gold. In the 1600s, the English chemist Robert Boyle explained that all matter is actually composed of tiny particles that behave in knowledgeable ways. He defined the difference between individual elements and compounds, and he explained the effect of temperature on pressure and pressure on gas. But one of the greatest scientists of this age was Isaac Newton, who linked science and mathematics. Newton theorized that gravity was the force that controlled the movements of the planets. He believed that all motion in the universe can be measured and described mathematically, and he continued to develop a branch of mathematics called calculus to help explain these laws.